Let's work on balancing some reactions together. So this reaction has zinc reacting with hydrochloric acid to yield zinc chloride plus hydrogen gas. So in order to balance this, I recommend writing all of the elements in the middle, and then we're going to determine first how many atoms of each type are on each side of the reaction, and then we'll figure out what's the best way to make things fair. We need the same number of atoms on both sides of the reaction. It's like a nice weight, and we're weighing them, we're balancing, we're trying to make things fair. So in this case, we have one zinc on this side, one hydrogen, and one chlorine. We have one zinc over here, two chlorines, and two hydrogens. So you can tell the hydrogens and the chlorines are not balanced. So in order to do that, what is the easiest way to balance them? Since we have two hydrogens and two chlorines on this side, we need two on this side. So let's try putting a 2 in front of hydrochloric acid. Now remember, you cannot mess with the subscripts to balance. You can only change the coefficients. And so it's just a game where you are changing coefficients to try and make the equation balance. So in this case now we've changed the hydrogens, so now we have 2, and we've changed the number of chlorines. So now we have 2 chlorines as well. So now our equation is balanced, and we are done with this equation. 1 zinc, 2 hydrogens, 2 chlorines on both sides. So now we're going to do a slightly more complicated looking equation, but it's the same principles that still apply. Just working on balancing. You want the same number of atoms on both sides of the equation. So here we have calcium hydroxide plus phosphoric acid yields calcium phosphate plus water. So when I'm doing things that have polyatomic ions on both sides of the equation, it makes it easier for me to not break them apart. So here phosphate is on both sides of the equation. So don't break it apart. Don't show me phosphorus and oxygen. Just put phosphate. So what I do in the center, I've got calcium, oxygen, hydrogen, and phosphate. And that's how I'm going to break it up. On the left side, I have 1 calcium, 2 oxygens, 2 hydrogens, plus 3 hydrogens. So 2 plus 3 gives me 5. And then I have 1 phosphate. On this side, I have 3 calciums, 2 phosphates, and then water. So we have 2 hydrogens and 1 oxygen. Now, never, ever, ever start with the easy compound. If I start with water, I'm going to be sad. All right? Start with what looks the most complicated. So to me, that's calcium phosphate. So I know my calciums are not balanced. So to fix that, I put a 3 in front. And now recheck all of my numbers. 3, oxygen times 2 times 3, so 2 oxygens times 3 gives me 6. 2 hydrogens times 3 gives me 6, but don't forget your other 3, so that gives me 9. Now, my phosphates, they were not affected by placing a 3 in front of calcium hydroxide. Are my phosphates balanced? No, so do that next. So let's balance those by putting a 2 in front of phosphoric acid. Now, I have 2 phosphates, but that also changed my hydrogen, so I have to go back and recount all my hydrogens. 2 times 3 gives me 6 hydrogens. 2 times 3 gives me 6 hydrogens, so I need a total of 12 hydrogens on this side. I don't know why I put a 0 here. This should not have been 0. This should have been 1. All right? So now let's go and check and see what all remains to be balanced. Our calciums are balanced and our phosphates are balanced, but our oxygens and hydrogens are not. This is where it would have been bad if you had done this one first. Okay? But now we've done it last, so it's nice and happy. So how am I going to make my oxygens balanced? There's 6 on the left side and only 1 on this side. So if we place a 6 in front, 6 times 1 gives me now 6 oxygens on both sides of the equation. Did that fix my hydrogens as well? 6 times 2 gives me 12. Yes, it did. And we are done. Let's balance this equation now. We have sulfur and we have fluorine. How many sulfurs are on each side? 8 on this side, 1 on this side. How many fluorines are on both sides? 6 on this side and 2 on this side. So I'm going to start by, once again, the most complicated one. That's this one. So my sulfurs are not balanced. In order to balance them, I can place an 8 in front of my sulfur. That now changes this to 8. And then we've got 8 times 6 is 48. So then, how many fluorines do I need? Starts out with 2, so 48 divided by 2, I need 24, because 24 times 2 gives me my 48. And now I am entirely balanced. And so this is kind of a more easy example, but it's a good example nonetheless. Let's balance another slightly hard problem. So in this case, we have carbon, hydrogen, and oxygen. 2 carbons, 6 hydrogens, 2 oxygens, 1 carbon, 3 oxygens, 2 hydrogens. So once again, I start with kind of the more complicated molecules first. So if I have 2 carbons on this side and only 1 on this side, I know I could put a 2 in front of this one, which would change my carbons to 2. My oxygens change. That's 4 plus 1 gives me 5. Now, what could I do next? This is 6 and this is 2, so I need to put a 3 here in front. So now 3 times 2 gives me 6. How many oxygens do I have? 2 times 2 is 4, plus 3 gives me 7. My carbons are balanced, my hydrogens are balanced. What about my oxygens? In order to make them balanced, I would need 3.5. Does that make sense? Have you ever seen a number like 3.5 on an equation? For the most part, no. And so in order to fix that, because 3.5 would give me 7, right? In order to fix that, you can just multiply everything by 2. So this would be 2 times 1 gives me 2. 2 times 3.5 gives me 7. 2 times 2 gives me 4. And 2 times 3 gives me 6. C2H6 plus 7 oxygens yields 4 carbon dioxides plus 6 waters. And that is my final balance.